All right, good morning and happy April Fool's Day. If you have any interesting April Fool's pranks that you've pulled today, or any good videos, I guess, you can always drop those in the comments on the Google Classroom page. But what's most important here for us today is that on Friday, we're going to have a quiz over all logarithms. We're going to go back to some interest, compound interest, not much simple interest next week, but we're going to have a quiz on Friday, so 2 days from now, on all of our log properties, and that will include log base e, or the natural logarithm. So we're going to work on expanding these logs. We want to get 2 logs out of this one. So what we're going to do here is we're going to look at the operation going on inside the logarithm. So am I multiplying? Am I dividing? Do I have an exponent? What am I going to do here? Another exponent. So we're going to do our order of operations. And we're going to look at, in here I don't have any parentheses, other than the log itself, so I won't worry about parentheses, no exponents. But here I've got multiplication. So I'm going to rewrite this. I want to expand. Again, I want to expand this. So I've got log of 6, log of 11. But if I'm multiplying, what operation am I doing with these 2 logs when I've split them up? What operation goes with multiplication? Well, multiplication makes numbers bigger, typically, and so does addition. So addition and multiplication will go together. And let's do number 3. I'll leave 2 and 4 for you guys to do. Now I've got this exponent here. So parentheses, don't have any parentheses, but I've got to do exponents next. And what happens to these exponents? Well, I can just take these exponents and drop them off to the left of the log. So 5 log, or 5 times log of 6 over 11. So 5 times the log of 6 over 11. And now I've got division going on in here. So I'm going to break this into 5 times log of 6, 5 times log of 11. And if I'm dividing, 6 divided by 11, if I'm dividing within that logarithm here, then what operation am I going to put in there? What operation goes along with division? Well, that would be subtraction. So our final answers here are just these expanded forms. You don't need to simplify. You don't need to worry about evaluating the log or anything like that. We're just focusing on expanding them. So why don't you just pause the video and try 2 and 4. All right, so I've got 1 log. I want to break that into 2 logs. Log of 5, log of 3. And if I'm multiplying, then I'll add in the middle there. So I'll add those 2 logs together. And let's do green. Now I've got log of 3, log of 2 to the 3rd. And I've got that that multiplication symbol in the middle. So if I'm multiplying, what operation goes along with multiplication in our log properties? Well, it would be addition. But there's one last thing to do here. I still need to get rid of this exponent. And the reason why I didn't do it earlier is because this is just part of, that 2. It's 2 to the third is the whole expression. So this is sort of like its own expression or number by itself. We could either move that 3 over and say log of 3 plus 3 log of 2, or we could just say, well, I know what 2 to the third is. I know 2 times 2 times 2 is 8. So a couple of different options for you to simplify that one. And now we're going to condense some logs. So I'll do 2 condensing. We'll do 2 solving equations. And then we're going to do 2 of the last ones. So I'm going to leave the whole right column for you guys to do. And I'll post those completed notes right after the video goes up. So I've got these instructions to condense each logarithm. So I want to take these 2 logs and turn them into 1. So let's just deal with this first. So I've got a number outside. And how did we get a number outside our logarithm just one problem before this? Just a couple problems ago, we took the number in our exponent and we brought it out front. So we're going to do the exact opposite here. We're going to take the number up front and we're going to put it where it belongs in our condensed form in that exponent. And if you want to, you can simplify that 8 squared. So you could say, log base 4 of 64 minus log base 4 of 2. And then if I'm subtracting those 2 logs, then what's going to go with subtraction? What operation goes with subtraction? Well, it would be division. So 64 over 2. And you could simplify that even further of log base 4 of 32. And that should get you somewhere between 2 and 3. And we're doing 7. So again, here I've got a number out front. So what do I do with that number out front? Well, I'm going to bring that up into the exponent. But since I have parentheses, see, and this is where doing our order of operations becomes very important. Since I have parentheses, I'm going to put this 4 up in both exponents. So what that will look like is log base 3 of 27 to the 4th minus log base 3 of 81 to the 4th. So those are the first steps that we can take. And if you want to, you can simplify these 2 numbers. They're pretty big numbers. Or you can leave them as they are. But I want to condense this, so I've got subtraction. I'm subtracting those two logs. So log base 3 of, and what operation goes with subtraction? Well, that would be division. They both make numbers smaller, so 27 to the 4th divided by 81 to the 4th. And again, I'm just going to do these last two on the left column, and then I'll leave the rest for you guys to do. I'll post the completed notes right after our video goes online. So number 9, we're going to look at solving these logarithmic equations. And here, let's see, what are we working with? Well, I've got log base 10, or just log of this stuff, equals log base 10 of something else. And now if I have the same base, then if I have the same base, what do I know about these two expressions? Well, if the base is the same, then those two parts have to be the same. So negative 2a plus 9 is exactly the same as 7 minus 4a. I can add 4a to both sides. That's not a great color. So 2a plus 9 equals 7. I could subtract subtract 9. Got ahead of myself there. Subtract 9. 2a is negative 2. A is negative 1. And number 11 here, I've got log x plus log of 8 equals 2. So what I'm going to do here is I'm going to condense this left side. I'm adding two logs together. Let's do it in blue. So 1 log of, and if I'm adding, then what do I do with the two pieces? 8 and x. Well, adding, I would multiply those together. And again, this is just log base 10. So we know what to do when I've got two logs equal to the, two logs that are equal to each other. But what do I do if I have a log equal to a number? What would I do then? Well, I really don't know how to solve this. But since I don't know how to solve it, I can still write this in a different format. I can still write this in exponential form. So I can say base of my log will be the base of the exponent. So 10 to the second power. So 10 to the second power equals 8x. Or 100 equals 8x. And x would be 12.5. So again, I'm leaving that right column for you to do. And I'll post that video here.